So you're training to become an airframe and power plant mechanic. Well, what does that mean exactly? What are the privileges and then limitations of what you'll be able to do once you become a airframe and power plant mechanic? What's going to be expected of you?
Okay, Part 65 covers the certification of airmen to include mechanics. Now, an airframe and power plant breaks down into three actual certifications. One is your general, which allows you to grow into an airframe mechanic or a power plant mechanic, or in our case, an airframe and power plant mechanic. Now, there's two ways that you can do that. You can do it through practical experience, but it takes several months and it's a long period of time, or you can go to a school like this one, and then you can graduate inside of it, about a year or so, if you successfully pass the oral and practical and the written test for each one of those general airframe power plant. Okay, so now if you just have your general, what are you able to do? You're not permitted to perform any sort of major repairs or major alterations to propellers or anything else like that. Most of these guys, and there's very few that actually have just their general, but they work on repair stations. But the thing is, you can go work at a repair station, and so long as you're operating under their certificate, you can get your repairman certificate and just work. There's not a lot of money in doing that, but it is a way to gain experience if you didn't have your A&P. Okay, so what about airframe and power plant? So once you have your airframe, you're authorized to perform 100-hour inspections and servicing on airframes. That means anything that's attached to that airplane minus the engine. Once you have your power plant, then you can do the 100-hour on the engine. What you can't do with your A&P is sign off annual inspections. You have to have an inspection authorization for that. Now, an inspection authorization means that you've been an A&P for a set period of time, and then once you've completed that time, you go and you sit and you take a final test, and then they say, "Hey, look, here's your IA." And it's different. Whereas like with your A&P, once you have it, you have it. You don't have to like recert or do anything like that, and it's you have it until it's revoked. Now, with an IA, on the other hand, you have to meet like certain requirements on the job training or continuing education, and you have to have a place that they can reach you. And there's several requirements that are much different than just having your A&P. Once you have your A&P, you have an airman number, boom, you're done. An IA is a little bit more involved, but they're the ones that are returning aircraft to service every single year. So it makes sense to have a little bit higher standard for those guys.
Now, the FAA is going to be very, very interested in your recent experience, especially if you try to go get your IA or for any number of other jobs. What is recent experience, and how do you recover recent experience once it's lost?
Okay, so Part 65 states that the mechanic, before exercising their privileges, has to work for at least 6 months of the preceding 24 months in one of three capacities. One, they just served as a mechanic, they're just working as mechanic, technically supervised other mechanics, or served in an executive capacity over the maintenance and alteration of aircraft. So basically, you got to be a mechanic, a team lead, or a manager of some variety in order to exercise the privileges of your certificate. Now, you'll never lose that certificate. You just won't be able to sign anything off for 6 months if you start and stop all over again. Now, on that, if you were to say lose your recency, there's a dozen different ways that you can kind of get started, get back again. You just have to do whatever one of those ways for 6 months to regain that recent experience. This could be just going to work at a repair station, getting another job, and then as a mechanic, and then not signing anything off, volunteering, any number of things that where someone will just vouch that, hey, look, for 6 months you've been doing X, Y, or Z for however as a mechanic. Once you're there, then you can turn around and sign things off again.
So now, as a mechanic, you're going to be using a lot of technical data to do your job. Now, that's going to come from a variety of different places, but one of them is going to be the manufacturer through his or their maintenance manuals, or their wiring diagrams, or their parts catalog, or any number of other types of data that they will produce and give to you. Let's talk about all those different types of manuals and what they mean.
Okay, so maintenance manuals. Let's talk about that. So, a maintenance manual gives you everything that you need to possibly know as a mechanic. And there's several different types of maintenance manuals. We're going to go over them one by one. But first thing that you need to know is like the starter point for everybody is the aircraft maintenance manual. Now, that the AMM will tell you everything that you need to know. It gives you a description of stuff. It gives you lubrication instructions, pressures and electrical loads, tolerances and adjustments for proper functionings of the airplane. Everything and anything that you could possibly need to know is going to be inside of that maintenance manual. It's almost always going to be a starting point for you. Even if, let's say, you're a structures guy and you're doing heavy rework, pulling spars out of wings, or you're an avionics guy that's only doing like modification work or troubleshooting different aircraft that come in, you're still going to have access to things. You're still going to have to remove and install things, and so everybody, regardless of what your role is, it's going to come back to the AMM. At least as a foundational piece. Now, once you're beyond the AMM, you could be in the overhaul manual. So, the manufacturer's overhaul manual contains a brief descriptive information and a detailed step-by-step instructions covering the work normally performed on a unit that has been removed from the aircraft. So, like a good example of this is the components maintenance manual that we used at Boeing, the CMM. So if you ended up having a problem with a item on the plane, you'd go to the CMM, which is a type of overhaul manual, and it would break down what that component is, rather than just trying to send that component off and get a new one in. You would get into the CMM and you would start troubleshooting and repair or replace or whatever it is of that individual item. You could have an overhaul manual for your power plant. If you're a helicopter transmission dude, you could be doing that. You could also work in a place that specializes in overhauls, and you will use the overhaul manual almost exclusively because you'll never see the aircraft. You'll simply get a box, and then inside the box is an engine. Another one, we'll talk about the structural repair manual. That contains manufacturer information on specific instructions for repairing primary and secondary structures. So, doing massive rework on the airplane structure itself. Or an IPC, an illustrated parts catalog. That's something that we're going to use on a regular basis to get part numbers and check the effectivity of parts, so on and so forth. The wiring diagram manual. When I was in the Army, they called these fold-outs because they were so big. You would open up this actual paper book. It was the one that we didn't have a PDF of, and so we just had like an old paper fold-out. We would open up the book and literally fold out these massive sheets, and then use those for troubleshooting any sort of electrical fault. So that's kind of your basic uh, aircraft maintenance manuals that you need to know about. A special manufacturer publication that will come out, especially if you are into private jets, are service bulletins. Now, service bulletins, or sometimes called service instructions, are several different types of publications that are issued by either airframe, engine, or component manufacturers. So these service bulletins will come out and they'll say, hey, look, we need you guys to do X, Y, or Z because we found a safety condition, or some sort of like non-conformity, or we found something in the factory that like this guy, like come to find out he was like asleep on the job, and we produced a bunch of parts that shouldn't have been produced, and so we need you to change these things out. Now, all these service bulletins will have estimated man hours to remove and replace these components. So, like, if you're a private jet guy and you get out there, you're going to have owners and pilots. They'll say, like, well, how much is this going to cost me? How long is the jet going to be down? And these service bulletins kind of give you an idea of like how to have that conversation. You can say, like, well, like this says it takes 10 hours, so it's going to cost you, $3,000 or whatever it's going to be, and it's also going to be out for a day or whatever. But that is a service bulletin. So, kind of related to the service bulletin, but though not coming from the manufacturer itself, is the FAA's aviation maintenance alerts. They provide a common communication channel through which the aviation community can economically interchange service experience and cooperate to improve the aeronautical product durability, reliability, safety. Essentially, it's a fancy way to say like, hey, look, I found this on my plane. I'm going to let the FAA know, and the FAA lets everybody else know. It's not quite to the level of an airworthiness directive because it's not like a common thing that we see on a regular basis to the point we need to do a massive change. It's just kind of a heads up to be looking for these types of things. If you say like, hey, look, I found this piece was melted on my airplane, you could simply let the FAA know. They put it in the service bulletin, they push it out, and then everyone else knows to, hey, look, whenever we're doing work on that type of airplane that I work on, we needed to look at that piece to see if it's melted. Maybe there's a trend here. Maybe it's just a one off of that one guy, but it doesn't help or it doesn't hurt to simply just be talking to one another. The last bit on this section is the minimum equipment list, or the MEL. You'll hear a lot of Part 121 guys or heavy commercial guys say like, "Well, we just MEL'd it, or we deferred it." What they're referring to is that in order for the airplane to be legal to fly, there is a minimum equipment list, and that's what MEL stands for. And so, like, as long as the airplane has what's on its minimum equipment list, then it's good to fly. You can defer whatever fault is showing up for for heavier maintenance later on down the road. In the Army, we called these diagonal faults. They didn't red X the plane. They didn't violate safety of flight. They were just kind of annoyances that we just had to deal with until we could find the time to do maintenance on it. Some examples of what you could MEL is, let's say, like the pilot's map light was out. Well, it's a burnt bulb, but we don't have a bulb, and we don't have time for it, so we'll just MEL that. We'll defer it until the next heavy maintenance where they'll be in a facility that'll have bulbs. One that would get MEL'd all the time in the airlines is IFE, so in-flight entertainment. You don't need to watch SpongeBob while you're flying to be safe. It's just kind of a nice to have to distract your kids or whatever. So if the IFE goes out, well, we just MEL it, call it, defer it to the next thing, and then go on about our merry way. Now you can find a plane's minimum equipment list in Chapter 25 of any maintenance manual. It should tell you like this is what like bare minimum the things that you have to have. Da 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 da. Like whatever that airplane is, whatever the configuration of that airplane is, you should be able to find it there and be able to make decisions based on that information. Now, another one that we'll mention here again is AC-43. AC-43 basically has kind of like the library of commonly accepted maintenance practices. And that's another term that you'll hear as a camp. So, like whenever you go to work at an MRO or an airline, you'll get camped on to their maintenance program, which is commonly accepted maintenance practices. This is basically kind of an overview of how they operate. There's other documents that could be drawn from AC-43 and the maintenance manuals and put in there into practice. A 121 or a 135 operation will have their approved maintenance program. Most of the time, it just follows the maintenance manuals, but they could have some little nuances, or some maybe they provide some sort of special service, say like they're firebombing or something, and maybe there's not a widely accepted or widely implemented documentation program and so they've had to come up with something on their own, and they've got that approved by the administrator. The important part to take away from that is approved by the administrator. You'll see that even on AC-43 here, that it'll say like these are the practices that are approved by the administrator, and that goes back to our approved and acceptable data. This is acceptable data for for working on on aircraft, as opposed to approved data that has to be approved directly for what you're doing. But just know AC-43, and there are some others, but the main thing that you need to take away is like what is approved and what is acceptable to the administrator. You can't just simply be doing the shade tree mechanic thing and just kind of like beating to a tune of your own drum. You have to work to some sort of documentation, some sort of plan for it to be legal and professional aircraft work.
Now, in those maintenance manuals and the service bulletins and that documentation that we were talking about, there's all kinds of fairly standard, cautions, warnings, notes, and every single one of them mean a certain, something. And so let's talk about all those standardized blocks that you'll find on a maintenance manual or a service bulletin or maintenance alert, and what they mean for.
Okay, so let's take. We're going to look at notes, cautions, and warnings. But first, I want you to see this page. Notice that this is like some really basic stuff. It's like how to use the maintenance manual. What are the notes, cautions, and warnings, and serialization. Notice that it's also in the bottom right-hand corner. This is page 2. Almost every maintenance manual you ever work on will have these introductory pages up front, just front matter. If you're new to the plane, you're new to that manual, it is very, very good for you to start by simply just like brushing up on what are differences inside of this manual. If you go back to our human factors class, we talked about the shell model. But one of the things that the shell model looks for is like confusion in the like maintenance manuals and maintenance practices. Is there some kind of like weird, the quote, software issue that's happened where they made the maintenance manual so confusing that people just can't follow it, and so like it's always good to review this. Now, this is the Lear 25's manual that we're going to be using throughout the kind of like the duration of this course. It's going to be our trainer. And so, like, this is what we're going to go on. But anywhere you go, one of the first things that you should do, and it should be part of their camp program as you come on, they'll say, like, hey, look, this is, the differences in our manuals. Now, we've been talking about differences, but notes, cautions, and warnings are fairly standard. They don't change that much, but they could. All right, so let's just go over what notes, caution, and warnings are per the Lear manual, and then we'll kind of go on from there. So first off, notes. Notes are used to call attention to specific procedures or information. Most of the time, whenever you see a note in a maintenance manual, it's going to be because there's some kind of weird thing that's happened, or there's a something that may not be painfully obvious to the person who's either working on it or whenever you're reading through the maintenance manual. Like for instance, like it could say like, hey, note, make sure that the grease gets into this place, or note, make sure that you have this circuit breaker pulled, or you'll see like, note, make sure that like nobody else is working on these things because this system will talk to that system and it'll mess things up, or you might get a false reading, or your inspection will always be invalid. The notes are really good to pay attention to before you actually get working, and which is a good practice before you ever start working. And we're going to hammer this into you. Sit down and read through all of the tasks first, and then once you read through all of the tasks and you have a good idea of what's going on, there won't be any of these like surprises as they go along. Or if you get to a note, we'll say like, hey, look, if you've done steps 1, 2, and 3, don't worry about the steps 4, 5, and 6. Just go straight down to 7. You won't you work through 1 through 6, and then you get to 7 and realize you didn't have to do the work beforehand, because that happens. So that is a note. Now, a cautions are used to call attention to methods and procedures which must be followed to avoid damage to equipment. So this is pretty standard. Caution for the airplane, warnings for people. So like essentially what a caution is doing is say like, hey, look, don't swing the gear if you have X, Y, or Z like locked out or whatever. Like a good example of this, even though this may be a warning, I don't know how it reads it in the AMM for an 8.7, but essentially there is a way to close the nose gear up on the 787 whenever it's down if there's not a certain pin in. And so like you could have a caution that says like, hey, look, don't do these things, or don't put it in in air mode if you don't have this pin in, because these things could happen. The nose gear could close up and you go slam right down onto the floor. That actually happened whenever I was at ATS. They went out on our side. I was up at Everett. This happened out at Moses Lake. But essentially, a guy got on, went to do some avionics troubleshooting. He put the plane in air mode. They didn't have the pin in. Down the plane went. If I'm remembering that correctly, it was several years ago. But essentially, like, that could be an example of a caution. Hey, look, if you do these things, you could damage the airplane. Don't do it. Okay, so now warnings are used to call attention to the use of materials, processes, methods, procedures of limits which must be followed precisely to avoid injury to personnel. So let's think about, like, what could be a warning. If you're troubleshooting something, that's like, warning, make sure that the battery is disconnected, and you'll see this over and over and over again. Like, make sure the battery is disconnected, make sure the fuel will shut off, those types of things. And those will become habits to you. But there's a lot of warning, especially on the bigger, more complex aircraft. It's like, warning, make sure nobody's working on the flight controls whenever you go to do let's say like an auto land test, or a auto flap test. I can't remember the name of that test off of it, but there are tests that you can run which will move the flight controls completely on their own. And you're talking about thousands and thousands of pounds of pressure, torque tubes that are spinning at very high RPMs. And if somebody is crawling around on there, or even doing something just benign, they're just looking at something, they could get seriously hurt. There's also times where you could get seriously hurt. Like, don't energize this circuit if you're doing X, Y, or Z, because it's going to cause electricity to flow in a way that's going to get you shocked. There's all kinds of these warnings that are in there, and these are the ones that you need to really pay attention to, because you only have one life, you only have two eyes, and you only have 10 fingers. And now, like, that means that you have a limited amount of mistakes that you can make, depending on the severity of that mistake. And you need to make sure that you're not doing something that's going to kind of eat up one of your 9 lives. So those are notes, cautions, and warnings.
Now, in the past, we've talked about effectivity and how different parts will have different effectivity codes that correspond with the airplane serial numbers. In some situations, there will be an actual effectivity code, and this is effective for line number point A to point B, or whatever it is. Let's get a little bit more familiar with effectivity and how it applies to our parts catalog.
Okay, so we talked about effectivity codes a little bit earlier in other videos, but let's just kind of give it an overview and we'll kind of dive into them again. So as aircraft are produced, different parts will get used. Sometimes this is a design change, sometimes it's a supplier change. If you build an engine that says, like, hey, look, this is where all of our exciter boxes are going to come from. It's like Brandon Sanders exciterbox.com, and then all of a sudden the world realizes that I don't know how to build exciter boxes, and they fire me, and I just go bankrupt. Well, if you still want to deliver jets, you're going to find a new exciter box, place. So you go to, like, actualexciterbox.com and you start ordering from them. Well, if, let's say, there's an issue with your engine and you have one of the Brandon Sanders era exciter boxes, then it's going to say, like, hey, look, this part number isn't good anymore. You need a new part number from the actual exciter box company. And so that means that, like, my part is only going to be effective on certain serial numbers of the jet, and then whenever it goes out, it needs to get superseded by the new exciter box number. And so we have to have a way to figure out which engine or which era does this exciter box go to, the new exciter box go to. And so the so what of that is effectivity codes. And so they can be very, very simple. So, like, whenever I was getting my gaskets for my Piper Cherokee, it was just simple. Like, hey, from this serial number to this serial number, this is the part number, and then from this serial number to that serial number, this is the part number, and that it just kind of changed. Just really simple that way. But whenever you start dealing with really complex engine, if you start dealing with like a 777 or an 87 or an A380 or an A321, they're there's a lot of complex parts that are in there. There's a lot of parts just to begin with. There's just a lot of them, and the way that they're arranged are complex, and the supply chains that supply those are complex. Because I mean, even if without the bankruptcy, like this supply house goes away and this one takes its place, they still do multi-source choices from these different suppliers, and so there could be like slight minute differences from one part to the next. And so like, how do you know which part works on what? And so you'll get a parts manual to say like, hey, look, if you're trying to replace this bolt, these are the part numbers that you could work, this one, this one, this one, and this one. And sometimes like one part is basically very similar to another part, or maybe it works for a different, so you'll get like effectivity codes that will dictate that. And every IPC is a little bit different on how they handle effectivity, depending on the complexity of the aircraft that's being maintained. Now, the one that you're looking at right now is actually pretty simple. It just says, hey, this type of airplane with these serial numbers, this is effective, or it's not effective. Let's look at a little bit more complex effectivity. Okay, so this is out of the Lear's IPC. You notice that it like doesn't have just serial numbers; it has a legitimate codes. So like that effectivity code A says so alpha is to be interpreted to 25-002 through 226. So that means that like from 002 of the Lear 25 serial numbers through 226, the effectivity code for any part is A. And then B, same thing, 002 to 0039. But it says through 045, except with the aircraft mod to include flat cabin floors. So that means that they're inside this serial number bandwidth, 41 through 45, there's 4 aircraft that had this mod that was done that all of a sudden changed the effectivity codes, or changed the effectivity of certain parts, so that we have to put a code in there to make sure that you're not ordering the wrong part or installing the wrong part to create an unsafe condition. The one right below it says when the aircraft are modded to include with a flat cabin floor. So there you go. So like, and you can kind of like read through those and see the different ones that are effective for certain things and effective for other certain things. Look at Juliet there, part of the figure item number 21 and subsequent duct assembly. So it's giving you an effectivity code for a very specific part of the plane and not the plane itself. So it's really important that you pay attention to those effectivity codes. The easiest way to do this is to look up the part, find the part number, go over to the far side where it says effectivity, and then go to the end of that chapter, and it should tell you, hey, look, these are where the kind of the nuances of that effectivity code. And that's just on the Lears. If you get into other aircraft, they'll have a different kind of approach to effectivity. The principle is still the same, but the way that they communicate it might be slightly different. So it kind of goes back to like making sure that you understand the manual that you're working for before you start to order parts and things like that. If you think of the military, so the military, they have a kind of a totally different system where they don't have to deal with effectivity. So on the OH-58, we just had like a P. It was like TM, a technical manual 1-1520-248-23 P, and that was our parts manual, and that was for all OH-58s. The only one that would get kind of weird depended on like the power plant that we had, because there was an India model and a Romeo model, and even those, they had different TM. So like you couldn't order the wrong part because you were in the whole wrong way. So effectivity was an issue there. That is a way to handle effectivity, is just simply by having its every subsequent submodel has its own TM. Now, most of the world doesn't do that because it's too expensive, and there's too many mods that are done, and guys that are trying to sell a large quantity of airplanes, well, they just sell it to whoever, and they kind of like mod the base model to whatever they need. So you need these effectivity codes. So let's look at a couple. Okay, so here's our service bulletin again. Notice that it looks very, very different, but also notice that effectivity doesn't go just for parts. It can go for a lot of things. In this case, it's technical data. So this technical data, this service bulletin, is effective for those part numbers or those serial numbers that you see listed there on the bottom of the page. The principle is still the same. It's still like this data, just like the part in the IPC that we just looked at. This data is used for these serial numbers, and so like if you're using this service bulletin on a serial number that doesn't fall within those ranges, well then you're doing maintenance not by the book, and you shouldn't be doing it. But the big takeaway here is to know that effectivity goes far beyond just parts. It also goes into a wide array of things. It's a system that gets used throughout aviation. Okay, here's like another example of effectivity being used outside of a parts manual. This is the front matter that we just looked at on cautions, notes, and warnings. Notice on the bottom left hand side how it says effectivity colon all. It means that this is how Lear as a company does their maintenance manuals. That they always, cautions always mean this, warnings always mean that, notes mean this, and so it means that effective on all the Lear 25s that they produce, this is what it means. And I'd be willing to bet that it means that for all of the aircraft they've ever produced. But yeah, so that is effectivity.
Let's talk about maintenance programs and what the manufacturer requirements are for different airplanes and different maintenance programs, and how that applies to our job and how we maintain our compliance with those maintenance programs.
Okay, so the two basic inspections that are going to have to happen per Part 91 is the 100 hour and the annual. Now, if you have a privately owned aircraft, you only have to do an annual legally. But you'll be doing the 100-hour lubrication per the maintenance manual whenever you're doing that annual. It's not really like that big of a difference or deal, because everything that you're going to access during the 100-hour, you're also going to access during the annual, generally speaking. Now, if you're operating a aircraft for commercial purposes or for flight training, then you have to comply with the 100-hour rule. Now, so that means that like if you were to have a privately owned aircraft and you fly 1,000 hours, you do one inspection a year. It's an annual, and then you do your 100-hour servicing, unless you do it right, and then you're going to be doing the 100-hour servicing per the maintenance manual either way. But that's all you're legally required to do for a privately owned aircraft. Now, if you have a commercially owned aircraft and you fly that 1,000 hours in a year, you actually have 11 inspections you have to do. You have to do a 100-hour every 100 hours, and you have to do the annual. Now, typically, the annual and the 100-hour happen at the same time, so you don't have to worry about that. But that's the basic two inspections that every airplane will have to comply with in one way, shape, form, or fashion. Once you get to the higher echelons of aviation, they may not call them that, but that's what's happening. They're accomplishing the same things, just under a different name. Now, the scope and detail of the items that have to happen are all in Appendix D of Part 43. So you have to have a checklist whenever you're doing an annual or 100-hour if it's commercially operated, and you're going down that checklist, and it's per Appendix D in Part 43. And a lot of the stuff is pretty straightforward, things that you would think that you would have to check. These are things like general cleanliness, instruments for poor condition, studs and nuts for proper torque and obvious defects, bolts, electrical system switches, floats and skis, things that are very obvious or should be very obvious to you. The mechanic will walk up and be like, these are things that I would want to check every single year, make sure that they work. We use a checklist so that nothing gets missed, and what is obvious maybe to the rest of the world, maybe it's not obvious to you, or maybe there's some sort of discrepancy in your level of thoroughness. And so this gives us a standardized way, like this is what everybody's going to check, this is what everybody is going to go off of. Now, an annual can be really extensive and can be a big burden, especially if you have a very complex aircraft. So if you look next to our flight school, we have a Praetor 500 right next to us. It's a $20 million jet. It's very complex, and it's a large airplane. It may be a lot to do a full-on annual every single year and check every single thing. And on top of that, It's a big, expensive jet that is probably going to be just fine in a lot of aspects. Where maybe some of the smaller airplanes might get more wear and tear, and maybe not. They're not built to the same quality. So there's an option for registered owners or operators to ask the FAA to do a what's called a progressive inspection. So basically, this inspection takes an annual and it chops it up into different phases. And so you will say like I'm going to do this part of the annual this year and that part of the annual next year and this part of the annual the year after that, and then we'll come back to the first part because it's been a while since we checked it, and we'll go through that. The Army actually uses this exact approach. Instead of doing all of the things once a year or once every 100 hours, they would do what we called a PPM, a progressive phase maintenance, and there's 15 different phases of that progressive phase. But by the time you get through all 15 phases, there's literally nothing on that helicopter that we hadn't checked. Okay, the other type that you can get into is called continuous inspections. They're similar to progressive inspection programs, but they apply to large turbine-powered aircraft that are, and they're a little bit more complicated. They will often be referred to as checks, and you'll hear airliners talk about A checks, C checks, B checks, so on and so forth, or Y checks. These like really like intense checks that end up happening. That is another type of progressive phase inspections that are happening, but they're broke down in the op spec of the air carrier that's operating them, rather than just off the maintenance manual. Another one that we should probably talk about while we're here is the altimeter and transponder inspections. Per Part 43, you have to inspect certain things on certain intervals, one of them being altimeter and transponders that happen every 24 months. So typically this will be aligned with the annual of a small, like you say, like a GA airplane. And so like every other annual, you have to go get a transponder check and an altimeter check, and you'll go to a certified repair station. They'll hook up a pedostatic kit to your plane, make sure that everything is reading right, make whatever adjustments are necessary. Now, this is really important because if you're reading the wrong altitude and you're transmitting on your transponder or through ADSB the wrong altitude, then you're a serious hazard to yourself and everybody else is flying around in the air because everybody else is expecting you to be where you're reporting that you're being. And so this is something that it really needs to take a lot of attention to make sure that it's done correctly. And we're going to show you how to do those checks once we get to the advanced avionics portion of the course. But those inspections happen every 24 months, and you can look forward to learning how to do them.
There's a dozen ways to skin a cat, and especially in aircraft maintenance. Just because a certain technique can be used doesn't mean necessarily it's the right way to employ that technique or the right time. So let's talk about compliance with manufacturer approved methods and techniques.
Now, regardless of what you work on or where you work, you will never do work that is not annotated or dictated from some sort of maintenance manual or guiding document. Even if you're trying to do something that's totally new, that no one's ever documented before, you're still going to have to work to either approved or acceptable data, which means that you would be writing letters to the FAA and being authorized certain certain types of work. This is where aviation maintenance meets engineering. You can't just go and just do whatever. You have to be authorized by something, and then that person that's authorizing you has to have a reason to authorize you. They can't just say like, oh well, like that sounds like a good idea. No, they're going to do tons of research and tons of work to try to understand what it is that you are attempting to do. And all that type of manufacturer information gets researched, analyzed, and then annotated in their maintenance manual, so that way we are working to well thought out plans and information. So no matter what you do, always work to the book. Follow the AMM task or whatever that you're following to the letter, and then whenever you get to the point where you're going to sign it off with in the logbook, you're going to say I followed it per, and then state the task. 23-22-01 or whatever the task number it is, or say like I did this per the maintenance manual, or this STC, or this AD, or whatever the guiding document is. You're always doing by the book maintenance. And you'll hear me say that over and over again. By the book maintenance. The jet is expensive. It comes with directions. Follow the directions. Do by the book maintenance.
Manufacturer maintenance manager is only one place, or one source of information that we'll use as mechanics. What are some other FAA databases that we're going to be pulling from to get the answers on things that we need?
Okay, so last part of this section, let's talk about like some databases and resources that are available. And we've already talked about these at length, so we're just going to go over them one more time. So you have all the manufacturer things like your AMM, your wiring diagram, structural maintenance manual, IPCs, all that type of stuff. You get to the more complex jets, you have FIMs like fault isolation manuals and component manual and overhaul manuals and things like that. Now, the FAA actually produces a lot of these types of databases for you to draw from, like the TCDS, supplemental type certificate data sheets, AC43. AC43 is actually broken down into several different advisory circulars. ADs are another one that will tell you exactly how to work. There is, and if at worst comes to worst, if you just cannot figure it out and you can't find anything to guide you, pick up the phone and call the Flight Standards District office and ask to speak to one of their maintenance-oriented examiners. You may have something that's wholly new, wholly different that no one's ever seen. I doubt it, because aviation's been around for a long time and we've been documenting it a long time. But you never know. There's always emergence in any complex system, so there very well may be something weird that you haven't found that needs to alert the rest of us. So pay attention to what all the FAA puts out there. They do a lot of good work to try to keep the flying public safe. Learn as how to implement those service bulletins and the maintenance alerts that come out to refine the art of being a good aircraft mechanic, which is a craft at the end of the day. You will never learn everything there is to learn, and you'll only just keep on learning new ways to learn different things, and that's what makes a good maintenance, aircraft maintenance technician over one that's poor. One that's poor just thinks they know everything and they just kind of do it however. The one that's humble and continually tries to refine the process and tries to refine the art will always be the better mechanic. I'll see you in the next class.